we have two vectors, a vector being 3x hat minus 4y hat plus 2z hat, and then b vector being negative 2x hat 0y hat plus 3z hat. So if we were to write these out, now these are the a vector components, and this is the b vector components. Make sure these are in correct order. All right. So the way I like to do my cross product using matrices is I like to extend my x hat, y hat. You can even go further and put the z hat down if you want to, actually. There's nothing wrong with that. All right. And then if you were to write these across 3, negative 4, 2, negative 2, 0, 3, okay? Then you can do the cross product by doing simply this times this times this, right? So this minus this, okay? So here, when we do that, we can factor out the x hat. So here, negative 4 times 3, right, minus 2 times 0 x hat, okay? And then plus, we can do this minus this, right? So here I have 2 times negative 2 minus, right, 3 times 3 y hat, okay? And then plus this minus this. Or you could have just went here without adding the third column, but you know, we have plenty of room here, so why not, right? So here I have 3 times 0 minus negative 4 times negative 2 z hat, okay? So if you work it out, do all the math, I think you're going to get negative 12 minus 0 will be negative 12x hat, right? And then if you were to do all this, you're going to get negative 4 minus 6, right? I mean minus 9, so you're going to get negative 13 y hat, and then you're going to get 0 minus 8, so you're going to get negative 8 z hat as your A cross B. Okay. So if you were to able to like represent this in a polar form, right? Now I'm not going to do this for you. You could do this on your own, right? This would be like sort of, I'm going to just do a rough sketch of what this would look like. First of all, it's going to be in a third quadrant because you got negative x, negative y. And then it will be below the xy plane. So if this is your x, this is your y, and this is your z, right? You will have, right, negative 12 this way, right? And then you have negative 13 in the y direction. So I'm going to go this way. So this would be your shadow of your A cross B. So this is the shadow vector, right? This is your I guess Rx, and this is your Ry, assuming that this A cross B represents your R, right? The resultant cross product. Then your Z will be below the XY plane like so, right, of -8, right? And the actual vector R will be this, okay? So now this would be your angle theta. Your theta will go from your positive x all the way around to the shadow will be your theta on the xy plane. And your phi will go from the positive z-axis all the way through shadow to your r vector. Right, this is your r. And that would be your phi. This here will be your beta, and this here will be your alpha. Okay? I'm not going to write all that in there. So you should be able to represent this in a polar form as, right? So r vector can be represented as the magnitude of r, comma, theta, comma, phi as your polar form. Practice that. Give it a shot and see what it can do. All right? All right. Moving on. Let's take a look at the next page here. Normally, right, cross product will have units. But for now, assume arbitrary units for the vectors given below. Like for example, if A vector has unit of meters and the B vector has unit of newtons, when you cross them, the product will be Newton meters or meter newtons. Okay, so units are important, but right now we're just using arbitrary units. All right, so let's take a look at the next problem here. We've got a vector here, and a vector happens to be 6 units long with 20 degrees from the positive x-axis. So I'm going to sort of draw this thing out so we can visualize what we're doing here. So here's your, I'm going to do this too. Get these out of the way. And then, all right, so A cross B. So I'm going to do my B in purple. So I'm going to just draw roughly. I'm not going to draw this thing exact, all right, just so I could visualize what's going on here. So here is your A vector, let's say. And that's 6 units long. And this angle here is 20 degrees, right? And your B vector happens to be in 4th quadrant because it's -35. And here's your B vector, and that is 3 units. And this angle here happens to be 35 degrees. So the theta between A and B vector happens to be 55 degrees. Okay? So A cross B is equal to the magnitude of A times the magnitude of B times the sine of the angle between A and B. N hat is the definition of cross product, right? So A cross B will have the magnitude of A happens to be 6. The magnitude of B happens to be 3 times sine of 55 degrees. But what is the n hat? Which direction is my normal vector? Got to use the right-hand rule, right? Come on, somebody give me an answer. Thank you. Into the page of negative z hat. Correct. That is correct. Right? Therefore, my A cross B is equal to, if you work it out, you're going to get negative 14.74, right? Arbitrary units z hat as your answer. Right? A cross B, and it will go into the page, which is negative z. Because this is your x, this is your y. Right? Now, we're going to do D cross C. All right, so D, which we will do this pink, and then C in green. Okay, so C vector is 9 units long and it's along 110 degrees. All right, so here's C vector. And this angle is 110 degrees, right? And then my D vector happens to be 4 units long, and it's 230 degrees, so it's in third quadrant. And this angle here is 230 degrees, and that's my D vector. So the angle theta between, right, D and C would be 120 degrees. Okay, so this is the angle between D and C. All right. So when I do D cross C, right, that is simply the magnitude of D, right, times the magnitude of C times sine of the theta between D and C n hat. Therefore, my D is 4, my C is 9, times sine of 120 degrees. Right? Now what about the n hat? Which direction is that? D cross C. Positive? Negative z hat. Right? D cross C will be negative z hat. Make sure you use your right hand. I see a lot of students using their left hand if they're right-handed because they're writing with their right hand and using their left hand. So D cross C, right, is equal to, if you work it out, you're going to get 31.18 for this. So negative 31.18 z hat would be your cross product. All right. Now that's all fine and dandy because these are just two-dimensional vectors. But sometimes we could have three-dimensional vectors like this. In that case, we can't really use this formula here because we really don't know the angle between it unless we actually do a dot product first to find the angle. Then once we find the angle of the dot product of this, then we can use this. But that's doing twice the work, I guess. So the best thing to do is to use the matrices when you have component form like this, especially with three-dimensional vectors. So A cross C is what we're going to do. All right. So A, which I'm going to represent with this. C, I'm going to represent that with this. And I am not going to draw this. Okay. So here I have A cross C. And that is simply the matrices. Again, if you want to extend it out, okay, if you want to extend it out, might be helpful. So here for my A cross C, I'm going to put the A vector first, which is 6, negative 5, and the Z is 0, right? 6, negative 5, 0. And then for my B vector or C vector, it is 3, negative 4, negative 3, 3, negative 4, negative 3. Okay? So if I were to now cross them, this would be simply this, right? Minus that. So here I have negative 5 times negative 3, right? Minus 0 times negative 4 x hat. I'm going to factor out the x hat. Next, I have this minus that. So plus, right? Here I have 0 times 3 minus 6 times negative 3 y hat. Ugh, I'm running out of ink. Not that much left. All right, we'll do our best. All right, now for the z component, here we'll do this minus this, or this right here. They're same things, right? So here I have 6 times negative 4 minus negative 5 times 3 z hat. So if you work it out, okay, if you work this thing out, you're going to get 15 minus 0, you get 15 x hat. Here you get 0 minus negative 18, so you're going to get positive 18, right? And then when you work this out, you're going to get negative 24 plus 15, so you're going to get negative 9 z hat as your answer. Now, if you have to do, instead of A cross C, let's say you do C cross A. For those of you who are paying attention, you know A cross C is negative C cross A, or C cross A is negative A cross C. So if we know that, we automatically know that this is going to probably turn out to negative 15x hat minus 18y hat plus 9z hat. But let's see if that's true. Okay, let's see if that's true. So C cross A is equal to x hat, y hat, z hat, and then x hat, y hat, z hat. And then this time we're going to put c down first, which is 3, negative 4, negative 3. And then 6, negative 5, 0, 6, negative 5, 0. So, if we work it out now, this minus this. Therefore, it is negative 4 times 0 minus negative 3 times negative 5 x hat plus, right, it will do this minus that, which is negative 3 times 6 minus 3 times 0 y hat. And then plus, we'll do this minus that. Therefore, 3 times negative 5 minus negative 4 times 6 z hat. So, when we actually do this, this becomes 0 minus positive 15, so it's negative 15. Then, your y component becomes negative 18 minus 0 is negative 18. And your z component becomes negative 15 minus 24, no, plus 24, right? Because minus negative 24 plus 24 becomes plus 9z. Wow, look at that. It's the exact opposite of my A cross C. Boom. All right. Any questions? All right, let's see if we can move on to the next page. All right. So the rotational equivalent of force is called torque. So torque is rotational force, basically, right? And the torque is given by tau is equal to r cross F, where r is the radius, F is the force. The radius vector refers to the distance from a pivot point that a force F acts on to cause a rotation. Okay, so this is the pivot point. So if you're, let's say you're looking at a door from top of the, door from the bird's eye view, right, looking down at it. So you're only looking at the top of the door like this, and this is the hinge that your door is on. So the radial vector here, right, is the distance from the hinge to where the force is being applied. All right. So consider a bar with a pivot to the far left. So this is the pivot point. If a 4 newtons of force is exerted at the radial distance of 1.5 meters from the pivot at 40 degrees to the horizontal, calculate the torque of that bar. So if you were to redraw this from a common point, okay, R and F, okay? So here, my R vector is going to look like this. Again, this is just arbitrary, right? R vector. And this is 1.5 meters. And the force vector is going this way with 4 newtons of force, okay, at angle of 40 degrees here. So this angle here, this theta between R and F is equal to 40 degrees. Okay? So we can now say, oh, okay, well, torque, this is tau, by the way. This is 6.283. All right, so here, torque is equal to, then, R cross F. That is equal to the magnitude of R, right, times the magnitude of F times the sine of theta between R and F and hat. Well, now it's pretty simple, isn't it? So here, my torque now is equal to, okay, R, which happens to be 1.5 meters. My F happens to be 4 newtons times sine of 40 degrees. But what's my n hat? Which way is the direction of my n hat? Negative z hat. Good. All right, good. Negative z hat is correct, right? Because R cross F, and my thumb is pointing inwards. Okay? So, that's correct. All right. Man, you have a question?
Yeah. So does it not matter that they're different units? Like one is 1.5 meters and the other is in newtons?
Correct. It doesn't matter.
Okay.
Yeah, it doesn't matter. They don't have to be in same units. All right. So when I work this out, what I get is I get negative. This becomes 3.86, and the unit is just meter newtons. Meters times newtons. Z hat. So that's the torque. And the torque will be going into the page. All right. Another application of cross product will be finding a force created by magnetic field when you shoot a charged particle into that magnetic field. Kate, you have a question?
Yeah, yeah. So for the last one,
Yeah,
when you write the cross product answer in that form,
yeah,
like negative 3.86, would that be the same as if you found it in Cartesian form and then did the magnitude?
yep.
So if you did that, then you would also get negative 3.86?
Most likely, yes.
Okay.
Yes, definitely. Now, that's true because this is on the xy plane and this is on the xy plane. You know what I mean? But if these are not on the XY plane and they're like this and like ones like that, like you know what I mean? If it's like if they're like like this, let's say, instead of on the XY plane, let's say they're like something like that, like on the space, you won't just get a Z hat. You would get like X, Y, X hat, Y hat, Z hat for your torque. And you won't be able to use this formula unless you know like this angle right here.
Oh, okay.
You know what I mean?
Yeah, but could you use that to find the angle if you needed to know the angle?
Well, I would use a dot product to find this angle.
Okay.
Because sine will have, positive from 0 to 90 as well as positive 90 to 180. So this will give you like a really weird angle if it's like bigger than 90. You know what I mean? So I would use the dot product to find the angle between like these two vectors like this rather than a cross product. That once you find the angle between these two, you can use this, but you cannot just put z hat down. It'd be just the n hat, and the n hat will be like perpendicular to my r and f, and this would never be just a z hat. It will be like x hat, y hat, z hat. So you'll just leave it as n hat.
Oh, okay.
Yeah, good question. Very good question. Yeah, so this again is in the xy plane. So you will automatically get a z hat, whether it's positive z hat or negative z hat, as your result of the crossing those two. But when they're out there out in space, then you're going to have to put that in the Cartesian form. That's the only way to do it. Unless you do it really extensively using all these crazy angles. But the dot product will only give you the angle between the two vectors, but the actual theta and phi would be just impossible without using the Cartesian form cross product. All right. 6. The magnetic force is given by force is equal to QV cross B. Now, Q is just a scalar quantity of how much charge this particle possesses, right? V is the velocity of that charged particle. This B field or the B vector is the magnetic field that charged particle experiences as it's flying through the magnetic field. Then this charged particle will actually feel a force acting on it because of that magnetic field. Now you'll learn about this more in detail in E&M if you're junior taking this next year. So don't get all bent out of shape. Just use the cross product of what we have, right? So if a particle with charge of 2 coulombs is moving with speed of 600 meters per second at 30 degrees to the horizontal uniform magnetic field of 5 Tesla, so the B field is going horizontally and the charged particle is going 30 degrees to that and it's moving at 600 meters per second in that direction, 30 degrees, right? Calculate the force and the direction of the force that this charged particle experiences as it moves through the magnetic field. It seems rather complicated, but it's not, because we know this. All right? And we'll use that. So we'll say F is equal to Q times the velocity cross B field. That is simply Q times the magnitude of my V times the magnitude of my B field times the sine of the angle between V and B n hat. Okay? So this here is the B field. Right? This is V. This is Q, which is just, this is just, you know, a scalar quantity, like a number, 2. So we can use this idea and say, oh, well, that's not that hard then. Q happens to be just 2 coulombs. V happens to be 600 meters per second. B happens to be 5 Teslas. I can't even afford 1 Tesla. This problem has 5 Teslas. Poverty sucks. All right. Now we have to multiply it by sine of 30 degrees. But what is this n hat? Which direction is my force when I use the cross product of V cross B? Umar? Negative Z into the page. Very good. So when I multiply all these out, okay, this looks like 2 times 600 times 5 is 6,000 times sine of 30 is half. So that looks like 3,000 coulombs times meters per second times Tesla negative Z hat. So you can say negative 3,000 newtons. Well, all this multiplied together would be just newtons. Z hat. You don't have to worry about that right now. That is your force that charged particle will experience. So it will like go this way, and then it will go, you know, circle like that. Like, yeah. It gets trapped in there, going in a circle. All right. Any questions? All right. Let's go over some answers for the multiple choice. And if you have any questions on that, you could stop me. You know, we can explain. All right. Nikita, you have a question?
How did you get the Newton?
Yeah, don't worry about it. Yeah, don't worry about that. This whole thing multiplied together just becomes newtons, and you'll learn about that in E and M. Yeah, don't worry. Yeah, don't worry about that. I just know it's going to be newtons because it's force we're working with. So. Yeah. All right. Any other questions? All right. So let's take a look at some multiple choice questions here. A vector is given by its components. AX is 2.5, AY is 7.5. What angle does vector A make with positive x-axis? OMG, that's easy. Come on. Right. So if you draw this thing out, you know, you should be able to figure out that AX is 2.5 this way, right? AY is 7.5 this way, right? So here is your A, right? And they want to know what this angle theta is, right? Tan inverse, right? And I believe you get 72 degrees. All right. You guys get that? A. What about number 2? Which pair of vectors could produce resultant of 35? Well, if I have two vectors, 15 and 15, only way this could do the maximum resultant I could get is only 30. It's like 15 this way plus 15 that way only give you 30. There's no way I'm going to get 35 out of this, John. Right? 20 and 20, I could get maximum of 40 or minimum of 0, right? Because I could go 20 this way and then 20 this way, right? And I could get 35 going this way. So I could go maximum of 40, or if I do it this way, I get 0. So I could definitely get this. So this looks good. 30 and 70, maximum will be 100. Minimum will be only 40, so there's no way I'll be able to get 35. Similarly, 80 and 40, no way. It's not going to get 35. Here, 90 and 50, no way. So B is the only correct answer available. Three, a vector has magnitude of 17 units, making an angle of 20 degrees with the positive x-axis, right? So if you were to just, draw a quick sketch, it's going to do one of these, right? So 17 units. The magnitude of the horizontal component of this vector is, they want to know what this is. Oh my God, that's so easy, right? You just do cosine of 20 times 17, and you should get A, right? All right, number 4. As the angle between a given vector and a horizontal axis increases from 0 to 90. So here, horizontal axis, right? So here, it starts here, let's say, and as it goes towards vertical, right? If we look at the vertical component of this, what happens as it goes from 0 to 90 degrees? What happens to my vertical component? Oh, come on. Thank you. It increases. Look at that. It goes bigger and bigger. And matter of fact, it becomes that vector, right? So it definitely increases. All right. Any questions so far? Yeah, these are like the concept questions they always ask in AP tests. All right. So here, vector A has magnitude of 10 units, making angle of 30 degrees. Right? Did anybody get an answer for this one? Nobody? Nobody even gave it an attempt. Oh, I'm just so hurt. What'd you get?
I had
A? 20?
Yeah.
Let's take a look. I got an F, actually. And I'll show you why. So here's my A vector, let's say. My A vector is 10 units, 30 degrees above, right? So here's my A vector. And if I find the AX and then AY and find the components of that, right? This here angle is 30 degrees, right? And if this is 10, this is AY is 5, and AX happens to be 8.66. So my A vector is equal to 8.66 x hat plus 5 y hat. And then my b vector is 25, right, units. And this angle here is 50 degrees. So the proper angle here happens to be 310 degrees. So if I find my bx and my by, right, my by happens to be, if you work it out, I think you get negative 19.2 y hat, and the bx becomes positive 16.1 x hat. So my b vector can be written as 16.1 x hat minus 19.2 y hat. So when I add these two vectors together, I get my resultant vector of 24.76 x hat minus 14.2 y hat. So the magnitude of that resultant becomes 24.76 squared plus 14.2 squared, and that comes out to 28.54. So F 28.54. So I get F. Did you
I
get?
just typed into the calculator wrong, that's why. I just double checked.
Ah. So did you get this too?
Yeah, when I actually did it, I just typed in like the square root, like the square things wrong. I think I forgot to square one.
Yeah. Sometimes they do minus 14.2 squared, and that screws people over too. So be careful. All right, number 6. Two vectors have magnitude of 3 and 8. 8-unit vector points directly in the positive x direction, and addition of these two vectors is 10 units. Okay? The angle between is given to you by this. So you can actually just do a plug and chug on this, and you should be able to get your C vector. So here's your A, right? No, here's your C, A and B, right? And then you're going to get, this is your C, and then you can find the angle. So plug and chug. So you can say 10 squared is equal to, right, 3 squared plus 8 squared minus 2 times 3 times 8 times cosine of theta, and solve for theta. And you should get A. Oh, sorry, you should get B. You should get B. 14.4. Baseball, right? Baseball field. For those of you who don't know how to play baseball, well, this is AP class, so this is kind of unfair question. It's such a biased question, right? So I know AP class, baseball is played in a baseball field, and infield looks like a diamond. For those of you who don't know baseball, right? And this is the home plate, right? This is the first base. This is the second base, and this is 30 meters, and this is 30 meters. Right? It's kind of funny because baseball, they don't really use metric system. But anyway, right? So they want to know, right, how far this is. Okay? Oh, come on, this is easy. This is 90 degrees, 90 degrees, right? So you should be able to figure out using Pythagorean theorem, right? 30 root 2. All right? Vector B has magnitude of 10. So its tail is at the origin and lies between positive axis and positive y-axis. It makes angle of 60 degrees with, so here's your vector B, and this angle here is 60 degrees. So this is 10, right? So we know that this has to be like 5, and this has to be 5 root 3, right? Or 8.66, right? So if vector negative b is this, so this should be negative 5, and this should be negative 5 root 3. So D. Okay? Number 9. Number 9. Number 9. Number 9. That's Beatles, by the way. All right. So if the vector A has magnitude of 5 and vector B has magnitude of 15, the magnitude of resultant vector C is equal to A plus B. Must be, so here's vector A, and here's vector B, right? If you look at the extreme cases, here's vector A plus vector B, right? So the resultant looks like 20 in this case, right? Or I can do vector A plus negative vector B, and the resultant here happens to be 10, the magnitude-wise. I mean, obviously it's negative 10, but if I could flip it. So this is the extreme case. And all other cases, right, all other cases can be between, 10 and 20. So anything here, it has to be less than 20. And if I continue going like this, it's going to reach 10. And then it's going to get greater than 10, greater than 10, greater than 10, and the maximum is 20. So it has to be between 10 and 20. Number 10, let the vector A equal to this. Magnitude of vector is, OMG, that's so easy. Right, so the magnitude of A is straight out the distance formula, 5 squared plus 6 squared plus 7 squared. And that should equal to 10.5. All right, let vector A be negative 8 plus x hat plus 48y hat. So my vector A happens to be negative 8, 48, so it's going to be like something like really sharply going up. The angle this vector makes with positive y-axis, it's this. You could do that, that's easy, right? C. Number 12, let vector A be 3x minus 5y plus 4z, and vector A, no, this is not right. This should be vector B, sorry. This is vector B. 7x hat minus 8y hat minus 9z hat, right? So if you were to just write down, 3x hat minus 5y hat plus 4z hat, and the vector B is equal to 7x hat minus 8y hat minus 9z hat. The resultant will be, right, Now we're going to subtract. So negative, negative, positive, positive. And then when you add them up, you're going to get the resultant of negative 4x hat, right, plus 3y hat plus 13z hat. And that looks like B. And if the magnitude of A plus B vector is equal to magnitude of A plus magnitude of B, and neither A nor B vanishes, that means A vector is not a 0 and B vector is not a 0. The only way this can be possible is if A and B are in same direction. If there are in any slightly off direction, it will never turn into this. So A is the only choice available. All right, any questions?